Hey there. We're going to talk some more about intermolecular bonding, and because we talked about the bonding that took place with the covalent compounds and said that polarity was an issue, particularly with water. And today we're going to get more into the nonpolar and nonpolar. But the big thing yesterday was the fact that we talked about how like dissolves like. In other words, polar molecules dissolve polar molecules. Okay? Now, that's what's taking place here. We talk about the polar molecules first. When a polar molecule bonds to a polar molecule, when dissolving occurs, in other words, it's not going to break apart, they're just going to stick to each other. One of two possible intermolecular bonds can take place. Hydrogen bonds or dipole-dipole bonds. One of the two has to happen, not both, just one. Let's take a look at the difference in how you predict which one is occurring. So let's take ethanol. There's ethanol right there. Ethanol is a carbon. That's methanol, actually. Ethanol has two carbons in it, but it's the same base area. So this is methanol. But methanol has 3 hydrogens around it, and instead of a 4th hydrogen on the carbon, that hydrogen is bonded to an oxygen, which means this is now a polar molecule. But the key to this is this hydrogen bonding to this oxygen. Now remember, when we talked about electronegativity, we said that oxygen is like the second most electronegative element on the periodic chart. Hydrogen is a little bit below middle, which means then that the sharing taking place between the oxygen and hydrogen isn't really sharing. It's pulling these electrons away. Now remember, hydrogen is just a proton, electron, if it's a normal hydrogen 1 isotope. There's no neutrons, just in a few isotopes, hydrogen 2, hydrogen 3, which is not very common. So most of the hydrogen we're dealing with here have just a proton electron. So the one electron is being ripped out of its hands, and the proton is all this is. So this becomes kind of positive. Remember that little delta squiggly thing, that lowercase delta? That's what's going on here. It is polar because the oxygen and its powerful electronegativity being in play with the hydrogen bonded to the oxygen, as I said. The pair of electrons in that single bond are being pulled towards the oxygen, causing the hydrogen to become somewhat positive. Not positive enough to be considered an ion, positive enough to attract negative particles in the area. That is the key. It's not really an ion, but boy, it sure acts like it, but it's got this little oxygen hanging on to it right now. Water, the solvent, is also polar. Having a positive in the hydrogen bonded to the oxygen and the negative part to the oxygen. Here's what that means. More beautiful drawings on my part here. So let's take a look at really what ethanol should be looking like. Ethanol. This is ethanol here. 2 carbons, all these hydrogens, and now you got this thing right here. Water comes along. Oh, that's just beautiful. Oh, it does my heart good to see water drawn so beautiful. That's actually pretty cool. Go to Willett and check it. Not a Hilton hotel. All right, so because this part of the oxygen, or of the water rather, is oxygen, is negative, and this part here is positive. Same thing over here. This part is negative, and this part is positive. For the exact same reason making that Hilton. I just love Hilton. It's a wonderful place to stay. Positive. So, what's going to happen here is this oxygen is going to be attracted to that hydrogen. All right? Or, if this is situated, in fact, I'll make another water here. I'm going to make some water. That sounds horrible. Hydrogen, oxygen, hydrogen, electron, electron. And since this is positive here, and this is negative here, positive, negative, and that means then that the hydrogen ions are going to be attracted, the hydrogen atoms will be attracted to that oxygen atom. In fact, they both are going to do that. It's not just going to be one molecule bonding to it. You get a bunch of molecules bonding on here for both the waters and the ethanols. In fact, it is virtually impossible, unless you have a really amazing lab, which does exist in the country. But if you cannot get these two separate, once you get water and ethanol together, you can't get it more than 95% pure. Okay? In fact, there's something called proof for selling alcohol, and proof is double the percentage. The highest proof alcoholic beverage you can get is 190. I believe that's called Everclear. But the reason why it's 190 or 95% is because you can't get the other 5% off. They are really strongly bonded to each other. But like I said, they can get pure ethanol out of that, but they have to do some special things. They cost a lot of money, and you know. In fact, if you put heat into your car, if you ever have had issues, or your parents have had issues with getting your car started, you put in a bottle of heat. Heat is pure ethanol, and ethanol will bond to the water in your car, and will get burned out if it gets sucked away. Now, if it doesn't get sucked away, it sits there and collects water from the atmosphere, puts more water in your gas tank. But, you know, wintertime, that doesn't happen very often. Summertime, that's an issue. Anyway, I digress again.